everybody! Today we'll be talking about what the coronavirus is. And I think I have a cure for it. First of all, what is the coronavirus? It's a serious respiratory virus, part of the class of viruses called coronaviruses. They're named after long spikes on the outer part of them, their shell. They use these spikes to hook onto cells so they can infect them. What are viruses? Viruses are like a message in a bottle. It's not alive. All it can do is simply go to a cell, release very many copies of its genome into the cell so that it can reproduce. How does a virus work? The first step of a virus's life cycle is entry. To enter your body, it must enter through your eyes, your nose, or your mouth. After it's entered your body, the coronavirus would use its spikes to enter one of your cells. Some viruses are latent viruses, meaning that they can lie dormant in a cell for a long period of time. This prevents other viruses from entering the cell and gives them an advantage. Next, viruses release their abundant copies of their genome into a cell. Those copies of their genome will begin forming into viruses. Then, those viruses will begin expanding the cell walls until the cell breaks and the viruses escape to infect other cells. After the viruses head out to infect your body, some of the viruses won't end up getting to cells, and they'll crawl through the bronchial tubes into your lungs, inflaming your mucous membrane in your lungs. This causes swelling in your lungs, damaging your alveoli, making it hard to breathe, and then your lungs would start filling up with fluid and pus, which in any situation is not good. I have an idea for a possible cure for the coronavirus. It uses CRISPR-Cas9, a naturally occurring gene editing system in bacteria. The bacteria use an enzyme called Cas, meaning CRISPR-associated, to log pieces of DNA from hostile viruses into their set of CRISPRs. CRISPRs are short, repeating strips of DNA. Then, the CRISPRs allow the bacteria to remember virus. Then, when the virus attacks again, Cas enzymes will remove pieces of the virus's DNA, disabling it, so it can't infect any more bacteria. This can be applied to the coronavirus. If it can be applied to other viruses, why shouldn't it be applied to the coronavirus? First, you would require strips of DNA from the coronavirus. This would allow Cas9 enzymes to recognize it, and you would give them a guide RNA for it. The guide RNA would have to match it, which, when in action, the CRISPR-Cas9 enzymes will check strips of DNA, and once they find a match for their guide RNA, they will remove that specific piece of DNA, which will be the virus's DNA. But there is a slight risk involved in using CRISPR-Cas9. It doesn't always remove sequences that are perfect matches. As long as the sequence of DNA that you require is similar to the sequence of DNA that is found, the Cas9 enzyme will remove it. There's a fix for this drawback. The Cas enzyme can also replace strips of DNA. So if you knew the strip of DNA that was removed, you can always replace it. I hope this cleared up everybody's doubts about the coronavirus. Bye. Thanks for watching.